Hello and welcome back. Today's topic is going to be one of my personal favorites called related rates. So related rates is pretty much just derivatives with a lot, and I mean a lot of words and word problems, because it's all word problems pretty much. So admittedly this isn't any new math so much as you're taking a lot of chain rules and keeping track of everything. So the best way to get good at this is just examples, because there's only so many different scenarios that they'll give you. Admittedly, unless I want to make this a 3-hour long video, which I personally don't, I'm not going to be able to cover every single example, but I can give you a couple, and then as well with the next topic, which is optimization, you'll get a lot of practice with related rates. So let's start off with one of the standard questions, right? Let's say you have a ladder, right? I'm going to actually draw the ladder over here in red, right? This is our ladder. We know it's 10 feet long, right? It's propped up against some wall, but it starts to slip. We know that it's slipping at a rate of 2 feet per second downward from the top. We don't know the rate slipping outward from the bottom, but we want to find that when it's slipping outward and the x value is 5, right? Which makes sense, right? Because let's say we do have some ladder. It could be like this, and then if it's slipping, it'll start leading down a bit, and then a bit more, until eventually, I'll draw this in red so you can see it, it'll just lay flat, right? So we're gonna find it somewhere in the middle here from perfect, not slipping, to slipping a little bit but not quite flat. Okay, well, we need an equation, right? We're doing math, we kind of need equations. How do we get an equation? Okay. Well, we have a triangle, right? We have, I'm going to call this distance A, this distance B, right? We know the hypotenuse is 10, and this is a right angle. So what does that tell us? Good old Pythagorean theorem, a squared plus b squared equals 100 squared, right? Okay. But now what? Well, we're given some values. We know we want x at 5, right? And just to be clear, this is x, this is y, but a and b, it doesn't really matter. Just pick a convention, stick to it, right? Well, we want dy dt and dx dt somehow, because we know what this is, but we won't need to find this. We're given the x value. Well, if this is dy dt and this is dx dt, I'm going to give you a hint. We're going to differentiate with respect to t, right? So I am going to switch over to x and y convention so it's easier to follow. So we're going to have 2x, because the derivative of x squared is 2x, dx dt plus derivative of y squared is 2y, dy dt, derivative of constant is 0. And we can all agree these twos can just cancel out nice and neat, right? And this is what we want, so let's isolate for it, right? We get dx dt equals negative y dy dt quantity divided by x. Well, we found it, and we can plug in x equals 5, and we can plug in dy dt equals negative 2, but what's the y value? If only we had some equation that told us it. So now, this is, where students typically get tripped up is backtracking to the right spot. So now, using this equation, right, we're going to say x equals 5, right, which is where we want it. 5 squared plus y squared equals 100, which is 10 squared. This is 25, so y squared equals 75, y equals root 75. And we're dealing with physical distances, so we can't have a negative distance, right? So, okay, we have our y value at x equals 5. We have our x value, have dy dt. Just plug and chug now. You get dx dt equals negative y, so, well, negative y times dy dt is negative, so they cancel out to get 2 root 75 over 5. Technically, you could leave it as this. You could also simplify, because 75 equals 25 times 3, which is 5 squared times 3, right? So what this becomes is now 2 square root of 25 square root of 3, right? These are all being multiplied over 5. That cancels, that cancels. You get 2 root 3, which I think is like, I want to say 3-ish, 3 point something probably. But in this case, we're not worried about the exact value. We're just worried about the process. All right, let's move on to another standard example. All right, for this next example, and this is also a very typical one, you're given some sphere. It's typically a balloon, and you're pumping in some water or gas at a rate. All right, in this case, we're pumping it, let's just say, I don't know, water in at half a cubic inch a second. And we want to find the change in radius over the change in time, where dv dt and r are these things, right? So, okay, well, we want dv dt. That means, or sorry, we have dv dt and we want dr dt, so we're going to have to differentiate this with respect to time to get dv dt equals 4 pi r squared dr dt, right? Good old chain rule. And let's see, well, we have that, we have that, we want that. So what you get is dv dt divided by 4 pi r squared equals dr dt, right? 4 and pi are constants. We have the radius value. We have the dv dt value. We want this value. This is just a plug and chug, right? So you get 1/2 divided by 4 pi 1 over 16 equals dr dt. Oh wow, these are some nasty units. So you get 1/2 divided by pi over 4. This is 2 over pi, right? Yeah. And the most common thing for these questions is also to include your units. And it's just a matter of, well, if you have a dt, you know it's going to be probably per second. And volume is going to be cubic, area is squared, and just distance is just to the first power. So 1/2 divided by 4 pi times 1 over 16. This becomes 1 over 4. Pi over 4. 1/2 divided by that. Keep, change, flip. That's what I did personally. And I got 2 over pi inches per second. All right. And one thing I do want to say before we move on to the next example, I do have this memorized personally, but I believe on the AP, like the beginning of the FRQ section, they give you these formulas, or they'll just give it to you during the question. But if you do enough practice problems, you should at least be getting a couple of the formulas down pat. All right, let's move on to one more really good example. All right, and now here's our last example. Say we have some cylindrical water tank, right? Such that the height is half of the radius. So double the height, you get the radius, right? We're told that the change in volume over change in time is -3 cubic feet a minute, and we want dh dt when h equals 4. Okay, well, what's the volume formula? Well, again, it's a good way to not just memorize formulas, but to actually make them make sense, right? Well, can we agree that if we just have the area of a circle, it's pi r squared, right? So like this circle down here has an area of pi r squared, right? But we want for this whole cylinder, and we want it to be a volume, so we're going to start off with the circular base and just multiply it out by the height. Let's take the derivative of this because we know we want dv dt, right? Equals, I'm going to say this is left, this is the right for our product rule. So we're going to have left pi r squared, derivative of the right, dh dt, plus the right, h, derivative of the left, which is going to be 2 pi r dr dt. Well, again, we're not going to move stuff around quite yet. Pi r squared dh dt, we have pi is a constant, we have dh dt, that's what we're looking for. We have dv dt, obviously. R, what's r? Well, if h equals 4, right, you get 8 equals r, so r equals 8 in this case. So we have r, okay. We have h, we have 2, we have pi, we have r, we have dr dt. Wait, we don't have dr dt. Huh. Any idea as to where we can get dr dt? Up here, right? So if you differentiate this, you get 2 dh dt equals dr dt. Okay, but that only gives us it in terms of dh dt, and that's what we're trying to solve for. It's not going to help us. It's not meant to give you the exact numerical value of dr dt. It's meant to let you substitute that into your equation so that you're only focused on, you essentially just eliminate a variable from your equation, right? So let me rewrite this now. We have pi r squared dh dt plus 2h pi, or sorry, 2hr pi, and then dr dt is 2 dh dt times 2 dh dt. Okay. Well, I'm taking it nice and slow because this is admittedly the first fun question in my opinion, right? Well, 2h is just r, right? That's what we said. That's not a negative sign, to be clear. Let me just do that, right? So this is just r squared times pi, and 2h dt is just dr dt. dr dt. Or, sorry, dh dt. Oh, I see. Okay, that was a mistake on mine. I apologize. I was reading from this line, but I was thinking in terms of this line, so apologies. That's my bad. Okay. Well, this is the same as this. So we get that, this is meant to be dv. Can't write straight today, it seems. dv dt equals 2 pi r squared dh dt, which really means that dh dt equals dv dt divided by 2 pi r squared. Okay, well, this is -3 divided by 2 times pi, we're just going to leave it as that, times r squared. What's r? R is 8, which is 64. So dh dt equals -3 divided by 128 pi feet per minute. Well, this is a weird number. Does it make sense? Yeah, because think about it, right? Let's say we started off at some initial volume, right, these waves, and we're draining from, let's say, here, right? As time goes on, the wave should get lower, right? And lower and lower. And most people, we just assume the lowest point, right, so like there would be, let's just say call it h equals 0, right? That makes sense. You could pick some other random reference point, but if you've taken just a wee bit of physics, you realize, yeah, you can pick a random reference point if you want to make your math like 100 times harder. So those were 3 fairly common related rates problems. Like I said at the beginning of the video, the best way to get good at these is to just practice. The Calc 1 book that's linked below has a lot of good questions on this. I think it's section 4.1 or 4.3, something like that. But it really just is a matter of practice, 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 because It's no new math. It's just making sure you can chain rule and do basic algebra, which, don't get me wrong, sometimes algebra is tricky. But like, just plug and chug, and I want to say 8 out of 10 times or so, if this is an FRQ question, you're going to be given the calculator. So yeah. As always, if this video was helpful, consider leaving a like. If I could improve in certain places, leave a comment. I try to read them all. If I was really helpful, even consider subscribing. But yeah, let's say this side, next video, right, optimization. And you can gladly take me up on the subscribing offer. But yeah, have a good day.